The CPS is the basic entity, as I said, in the Industry 4.0 implementation. And then collection of many CPS should be able to give us a particular production performance. And once again, if you want a different kind of production performance, you should be able to once again change the um, this array of CPS in a different form, and then it will give us something different. I mean, some different kind of performance. This is quite similar to those Lego toys that you might have seen before. Sorry. So with the Lego toys, you have some basic entity, and joined together, you can make any shape. You can make any toy. You can make a lion. You can make an elephant. You can make a car or whatever. Because the basic element in all these is the same, and the same is true for this Industry 4.0 implementation as well, because the basic entity in all the Industry 4.0 concepts, so in all the factories, is the same. All you need to do is just rearrange them to make something new. So this modularity, for instance, I can give an example. Let's say there's a bottle filling plant, right? Now the bottle filling plant, it would use maybe a bottle has to be selected, and then a drink has to be selected, and the type of drink has to be selected, and then there's a filling station that would fill in the bottle, and then the bottle would travel and it will be collected. Fine. Now, when you talk about this modularity, so what we're saying is that the conveyor belt that you designed for the bottle to travel, the same conveyor belt we should be able to use it elsewhere also. I mean, it's like modular. So with slight changes, we should be able to use it at different places. Similarly, the filling station, it should be again modular. In different types of concepts, it should fit in. So all the entities that we use in a production line, they should be modular, and they are not specific for a particular product, but we should be able to use them in different production lines for different products, because they are modular. Now, next we talk about the basic fundamental building blocks of Industry 4.0. Now, this is the catch. See, we've been talking about these building blocks individually, many times. So, for instance, we talk about artificial intelligence and machine learning. We talk about big data analytics a lot. We talk about robotics. We talk about augmented reality and virtual reality. We talk about additive manufacturing. Now, these are the things which we have been talking about. Now, what Industry 4.0 does is, what is this concept of Industry 4.0 is that all these new inventions, all these new concepts, they are put together, bundled into one big thing that we call Industry 4.0. It's that simple as that. So you have Internet of Things, you have robotics, you have artificial intelligence, you have CNC and additive manufacturing. All these put together, the package becomes Industry 4.0. Because all these are leading us to the achievement of Industry 4.0 principles. And so what potential implications we see when we have these technologies? The Industry 4.0 concept, we have a production that is assisted by robots. Because if you have to transfer product from one machine to another machine, and if there's no person there, if there's no human there, you need robots, which will do it with great accuracy. We need to have predictive maintenance. The machine should be able to tell us that it needs a maintenance after 7 days, it needs a maintenance after 7 hours, whatever. And then for manufacturing, if you're saying that the manufacturing also has to be modular, I mean, the same manufacturing setup, we should be able to use it for other products also. Now, how is it possible? So, instead of the conventional manufacturing tools that we have, like lathe machine and drilling machine and milling machines, what is recommended is that we should have additive manufacturing equipment. I mean, additive manufacturing means there are many names to this. We call it 3D printing, we call it digital printing, we call it inkjet printing. So these days there's very different kinds of 3D printing machines are available. You can print using plastics, you can print using ceramics, you can even print using metallic. You can even print metallic parts. So there are metal 3D printers available. And so just given command, this machine can print anything and everything. Now, machines will become a service provider because, as I was telling you, like one machine provides services to another machine and it goes on. The quality control could be driven by big data analysis. So big data analysis is like, because through sensors we are collecting a lot of information, we should be able to perform analysis on this big data and find out what kind of quality are we going to achieve. And then the production line simulation tells us if you want to make any changes, what will be the effect. So instead of doing a hit and trial with physical systems, we do it with the simulations and and get the results quickly. The supply chain again has to be smart. For instance, we should know what are the demands coming from the market. How much do we have in the warehouses? How much do we have with the wholesalers? And how much do we have in our inventory? And how much we need to produce? So the entire supply chain, it starts from the need, from the demand, and comes down to the supply. And then a decision can be made up on how much to produce. So everything has to be, the supply chain has to be optimized and made smart. So these building blocks that I was talking about, which put together in a bundle, and we call it Industry 4.0. We'll quickly go through these building blocks to see what do we mean by how do we understand these building blocks. So the first one's like autonomous robots. So it's just an example that I have on the screen, but robots, if you talk about industry, the process industry in particular, there are pick and place kind of robots that would pick a product from a machine and would place it onto another machine's table. That's the basic robot that they use these days. That are being used in industry. But apart from these, there are robots who can hold something, who can perform certain machining operations, who can do painting, polishing. There's so many operations a robot can do. Now, when we talk about robot, it's basically it contains of it performs three basic operations. Now, these three operations are perceiving, making decisions, and actuating. So these robots, they have sensors on them, so they can see, they can feel, and if you talk about the chemical industry, they can even check the concentration or these kind of things. So let's talk about this pick and place robot, which is picking from one station and putting a job onto another one. So it can see, it has camera, it can see the product, and as soon as the product comes, it will reach there, because it has made a decision that whenever you see a product, you have to reach there, and then using your grip, you have to hold it. You have to hold it with certain pressure, because there's again pressure sensors on the grip that would tell the robot how much force has been applied, what kind of material is there. Through camera, it can scan and find out what kind of material is this, if it is iron or it's aluminum or a plastic or a rubber or a soft thing. So accordingly, it would decide on the weight and would decide on the gripping pressure. So it can perceive through sensors, and it will go there, make a decision, will go there and grasp it, and then it has to be placed into another machine. So the motors have to be actuated exactly the same amount, so that the next location where it drops the product is the second workstation. Now robots, they can be made intelligent. When you're saying that, when these are the functions of a robot. These three functions which I've told you, these are the functions of a simple robot. But when you talk about an autonomous robot can actually make decisions more intelligently. So what happens is the same robot, given a different working conditions, if there's a change, for instance, instead of product type A, now there is a product type B, and now this product type B has to go to another machine, and so the robot will be able to make an intelligent decision, and we'll also do the sorting operation. We'll be able to differentiate between different products and can place them on different tables. So we need autonomous robots for Industry 4.0. I was talking about this creating a digital twin of the industry, or creating the entire industry in silico on your computer screen. And this is possible, as you can see on this screen here. We've got a layout of the industry here, where we start from predictive machine analytics, and then move on to industrial augmented reality. It is all implemented to collect the raw material, process it into the machines. There are IoT sensors which are talking to the supply chain management how much to produce, making the decision how much to produce. Then there are cobots. I mean, of course, these are robots, but because these robots are working in collaboration with humans, we also call them cobots. So these cobots will then pick it from here. These are the cobots I'm talking about. They're picking the product and then placing into the bins there. And then we got computer vision. Computer vision would scan the entire thing and will do the quality control. Okay, all the equipment that we're talking about, they're all modular, and then it goes into final to the warehouse. And there we do everything like a blockchain for ERP and SCM or supply chain management. Even the truck can be an unmanned truck, and the person putting goods into the truck, either it could be a robotic system again, or if it is a person, this person is has put on some variables. If you can see on his legs, there are variable device which helps this person to lift heavy loads, and he's able to carry it. Oops, how do I get rid of this? Suppose this is an eraser and clear my annotations. Fine, thank you. Now, so there's another building block of Industry 4.0, and this is really important. Here we're talking about the cyber security, the data encryption, and I'll give you a few examples to make you understand how important this cyber security is when you're using internet to communicate. When you use internet to communicate, it's highly likely that the data that you would send through internet, though it will be encrypted, properly encrypted, understand. But still, there are hackers who are ready to welcome your data, to take your data, and they can decrypt, any difficult algorithm. So it's important that the encryption algorithm has to be very, very strong, robust, and so that the hackers cannot break the code. Now, few of the examples here in 2013 of October, Adobe, they announced that they lost information of their personnel, and that too was like huge. 150 million accounts were stolen. Once again, Sony PlayStation Network was attacked in 2011, whereby personal data of 77 million users was leaked. South Koreans, they one fine morning in January 2014 learned that 100 million of their credit cards were stolen, were hacked from internet. There's another second largest US counter chain called Target. It became victim of this very large scale cyber attack in December 2013, and it's 110 million accounts were hijacked, and that that included banking data. So um, this encryption of data is again very important when you're talking about implementation of Industry 4.0, and you're using internet for communication and also sending your data to cloud and receiving from cloud. We all know what is this cloud I'm talking about. Uh, these days, lots of people they use cloud. Now, why people would use cloud is because um, the clouds can rent you any kind of computing facility. Sorry, oops. Yes. So the clouds they can rent any kind of facility that you need. For instance, um, I have PhD students, and if they're working on some a particular software which I don't have, and it's pretty expensive to purchase. So what I'll do is I'll ask him to go to cloud, rent that software for his particular application, and get the work done. So he'll send the data to the cloud. We'll use this software sitting on the cloud the way he would use it, on his desktop, and then get the results from cloud, and we'll use it. The good thing about the cloud is that you don't have to have a very high performing desktop or a laptop. You can use a simple lean desktop and laptop, which is like basic configuration, and you're still able to do simulations which require actually maybe a high performance computing or a supercomputer. So something that a supercomputer can do, I'm able to do on my simple laptop or a basic laptop. How? It is all because of the cloud. Because all I need to do is I need to send the data, and then uh, using cloud, I'll be able to access server placed distantly, and it comes on my screen, and I can use it as if I'm using my own computer. Now, the cloud, as I said, is upcoming, and lots of people. I mean, there are lots of companies who are into this market, and they are making lots of money actually. These are the top 10 rankings I'm showing here. Um, I'm talking about this table where I'm showing, you know, um, the top 10 ranked companies, starting from Microsoft, Amazon Web Services, IBM's Web Service, Salesforce, SAP, Oracle, Google, ServiceNow. I mean, this ranking it keeps changing a little bit. I mean, if you look at it this in 2021, probably it will be slightly different. But the first five positions they don't change, and it says that the Microsoft is still on top. Now, these companies like Microsoft, they would earn a lot more than what they earn from their computers. I mean, using clouds and cloud-based services, they earn more the money that they earn from selling computers and other softwares. So, of course, there are private clouds. I mean, big companies they have their own cloud, and they can manage and maintain it. So, but um, for enhanced performance and I mean efficiencies, it is recommended to use the existing cloud services, which comes very cheap. Another building block of Industry 4.0 is this additive manufacturing and augmented reality. This augmented reality basically is, if you have used some solid modeling software, so like SolidWorks or Pro Engineer or So what we do is we create a product there, and then we can actually check how this product would be performing. We can check how strong will it be. We can check how it will be moving, the mechanism, anything we can kind of see there. Now, and then once you're settled with this, all you need to do is you need to connect your computer to a 3D printing additive manufacturing facility, and it would print. So they say that in future these big manufacturing plants would lose their meanings, and eventually what will happen is uh, every household will have a 3D printer in place in your backyard or in your garage. And if you need a part, you talk to the company, and the company will send you the designs. Will send you the drawings and the designs. All you need to do is download the design and connect the computer to the 3D printing facility, and it will print it out. So, for instance, if I need a plumbing accessory, or if I need an electric accessory in my house, or if I need any furniture accessory, all you need to do is just print it in my backyard and then use it. But that's something which is the final goal. But for now, the additive manufacturing and the augmented reality, it helps implementing Industry 4.0 concepts. And these are the major areas of application of augmented reality, where we talk about human-robot collaboration, uh, assembly, repair, maintenance, training of people. I mean, for instance, you're using a machine, and the machine is broken now. Now, the service engineer is sitting in another country, which is like 7 seas apart. So what you do is you talk to the person, and this person will guide you through the entire maintenance process through augmented reality. It'll tell you how to service your product, how to open the machine, how to find the fault, how to replace the part. You can even 3D print your part at your station, at your workplace. And then so through augmented reality, the person sitting far off, 7 seas apart, as I said, is able to make you visualize the entire maintenance as if it is done in reality. So, I mean, augmented reality in itself has lots of benefits. But as I said, Industry 4.0, it encompasses all these building blocks into one. And we're making use of all the available novel technologies so that we can spearhead towards the goal of achieving lights of industry. So next, I'll talk about some of the applications of Industry 4.0. Maybe before that, I can talk about little about my own experience with with a student project under Industry 4.0 course that we organized. So I work in Kazakhstan, which was earlier part of Russia. In my university, we offer this course on Industry 4.0 to students. Now, during the project, the students, they were asked to make a factory, a physical factory, which works on the principles, on six basic principles of Industry 4.0. So there were different teams, and they were asked to make design components of the factory. They should be modular. So modular saying that if there are 3 designs, so I should be able to pick one module from first design and should fit into the the third design or the second design. So these were the concept, and the factory that we chose was filling. It was like a when you go to the juice center and order a particular kind of juice. So the person will ask you like, do you want a small or a large cup? And then the person will ask you what kind of juice do you need, and then it will fill in and give it to you. So the entire factory that the students created, it had one one system that would select the cup. So the person comes to the station and gives an order that I want a small apple juice cup. So there's a robot which will pick the small glass. So it will do the sorting between small and the large. It will pick the small glass, put it on the conveyor. Conveyor then moves, stops at the filling station, and then this cup which is talking to the filling station saying that it needs apple juice, and so the machine understands and then selects the kind of juice and appropriate quantity. Like a small cup probably would need 200 ml, and a large would need 300 ml. So it would fill in the cup with the required amount of apple juice. And again, the conveyor will start moving. So the conveyor has to stop and start at different times. And so the conveyor would start moving again. And then there's a tray where the cups would be collected and sorted. The small and the big would be sorted differently. And then the customer can pick it up. So that was the kind of sorry, I didn't play the video. You cannot listen to the video, isn't it? Are you able to listen to it?
No, sir. The voice of the video is not available.
Sorry.
I can hear you.
Can you not see video?
A video we can see, sir, but now it's
But you
stopped.
cannot listen. You cannot hear, right?
Yes, sir.
Okay, I'll quickly. So this is my colleague from Turkey. Together with him, we conducted the course and gave it to the students. And the students, they did marvelous job. There's another video where we show students project, but maybe quickly I can. So this is kind of a filling station. So for filling, different teams, they use different type of tanks and filling stations. They're sharing their experience with us. And finally, when it worked, they were really excited because everything was talking to all the different components. They were talking to other components via internet. They use MQTT protocol uh, for, for for communication between components, and the filling station was working very nicely. So this would pick it up, and the drink would be prepared. Sometimes there were problems that they had to use like hands, and then would do the sorting and all that. So basically, when we talk about Industry 4.0, now we started talking about the applications. Okay. Am I audible? Can you hear me?
Yes, sir. We can hear you.
Okay, good. Thanks. So, as I said, that the ultimate goal of Industry 4.0 is to achieve a lights off production center. Here we're talking about minimization of waste, optimal processes. So it's very close. The idea is very close to the one we talk about in lean manufacturing or the smart manufacturing. Now here, you all know what are CPS. We talked about it, cyber physical systems. So we have cyber physical systems, and then there are advanced sensors, and they work together and control the production process. That's why. Now, so the smart manufacturing, it has basic components, and we'll talk about these components now. I cannot move this annotation. Okay, there it is. Yes. So now, so for that, we may have to redesign some of these things. For instance, we start with the equipment. So there are companies who would not have proper equipment, and so the CPS together with the advanced sensors embedded with the equipment can make them usable for Industry 4.0. Now, sometimes the companies They need to analyze the data available from and treat the maintenance schedule. As I was telling you, uh, planning it ahead and doing maintenance strategically can reduce the downtime. So basically, all we are doing in the direction of reducing the downtime of a machine and increasing its performance. Now, to achieve smart manufacturing, uh, the workspace has to be redefined. Uh, like the managers, the technicians, the inspectors, the process operators, they all can talk to each other through internet, and they can also communicate with the manufacturing machines. Now, so we need to actually create a digital thread. We will call it a digital thread, which has all these elements into it. So, right from the customer's demand to manufacturing capabilities and how the process should be aligned, uh, everything is there in the digital thread until the inspection of the products. So, after equipment and this redefining the workspace, we talk about the products. So to achieve Industry 4.0 concepts, the products should have RFID tags onto them, onto the products, on the packaging. Now, uh, when the product is reaching to a workstation, the machine, because the machine is also smart, it will be able to identify the component, what kind of component it is, and we'll also know what is the status of the component, what the operations have been performed to the product, and what are the operations that the machine has to perform on this product now. And then the product further goes into another machine. Now, this RFID tag, it could be as small as you can, like, have it on your fingertip. That's fine. Now, take an example. Take for an example. If you if there's a bottling plant, and the bottling plant has to fill in the shampoo in bottles. Now, as you know, the shampoo, they come in different variety. There are different kinds of shampoo. I mean, in order to sell more and tell more and reach out to more people, the companies, they have come out with different kinds of shampoo, different brands of shampoo, and so all, well, maybe the basic ingredients, they remain the same, but the perfumes and the colors, they are different in different types of shampoo. And so the bottle itself has a RFID tag onto it, and it is conveying to the machine that what kind of color it needs, what kind of perfume it needs, and then it will be done. So the products, they need to be smart, and we also need to optimize the supply chain. So basically, whatever we produce, it should be demand driven, and we want to reduce the inventory and the replenishing. So it is also possible, again, based on uh, this CPS concept of products, where the CPS can perceive through sensors and can act upon. Now, there's a very interesting example of such kind of a concept implemented in two different industries. One was Dell Computers, and the other one is Cisco. So they started implementing the concepts of Industry 4.0. Um, see, Industry 4.0 concept, there are more advantages where you have different, where you have diverse products, and these are customized ones. Okay, but at the same time, when it comes to the mass production, definitely, why not? This Industry 4.0 is obviously helpful, valuable. It helps in optimizing all the processes. As I said, we can reduce the inventory and replenishing, and can produce the optimal quantity based on, because we know everything. We know what are the customer demands, how much is kept in the warehouses with the wholesalers, with the retailers. and can make a decision. So overall, while it can help in mass production, Industry 4.0 is more suitable for customized products. And see, when I started my discussion, I was explaining you this Taylor's bathtub principle, and I said um, before the 20th century, we were the market was of customized products because there were artisans and 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 small craftsmen who were making goods as per the requirement and specification provided to them by individual customer. And then there was a long 1 century long era where we talked about mass production. Now once again the era of customized product has come back, and because our capabilities have increased, we are able to cater the needs of individual customers by providing them customized products. And so that's where the Industry 4.0 concept comes into picture. It's so much so that, see, I was talking about having your own workshop. I mean, the ultimate goal is that every household should have its own workshop. So things are not procured, but what you purchase is just the design of the drawing, and rest of the things you manufacture in your garage. So it's kind of a very customized products that you can make. At the same time, you can also do the mass production. Now, these two companies I was talking about, the Dell Computers and Cisco, they tried implementing Industry 4.0 concepts. And while Dell Computers, they had no problem uh, because their types of products were not very large. But the Cisco, they eventually were not very successful because they could not redefine their workspace. They could not um, change their products. I mean, they had more variety into the products compared to the Dell computers, and diverse diverse products in Cisco that Cisco makes. They're huge. They're big, and they require specific machines, which were not which they were not able to kind of uh, convert into a general capacity machines, and they eventually failed. So we do have such kind of examples where it's called build to order. So build to order, it was adopted by Dell computers and it was adopted by Cisco also. But Cisco could not build to order because um, they had a kind of a rigid production line, and the products coming, I mean, the orders coming to the company were very diverse. So they had to like change their production line quite frequently, and they could not afford to it. There's another example of a cola fizzy drink. Now, the customer is also a crucial entity into the entire paradigm of industry. Right? We need to understand the customer's demand. We need to understand the customer behavior, customer mood. There's so many things that you can that we are able to judge from the customer side, and it is also it all is possible. It's all possible with the big data analytics. Now, the company actually they changed their formula. They thought that their sales have kind of reached a stagnation. It's not increasing. It's not decreasing. It's not increasing as well. So they wanted to kind of revitalize the brand. So they changed their formula a little bit. And so what happened is the customers they didn't kind of like it, and eventually the sale dropped down compared to the because whatever the opportunity lost, it was taken by other companies. The other companies fidgeting started they started selling it in that place, and so this is how it says that big data analysis is very important, and it can provide the customer's experience. So before doing any intervention, before doing any changes, it is recommended that um, proper big data analysis and its results be taken into simulations, and the results should be studied. Yeah. Now, when you talk about, oops, how do I change this? Oops. I'm just trying to move my annotation and the toolbars, but I cannot. Okay, there's a problem. Maybe I can change this. Give me 1 minute. Shouldn't take long. Yes, done. Yes. So, you know, I have an example once again here. And the example I'm taking of this shampoo variants. So you have, let's say, three or four kinds of shampoo that has to be filled in the bottles. And if you go by the conventional industry 3.0 concept, the previous concept that we had before industry 4.0. So in the figure here, as you can see, there are three resources, and there's a controller. This is controller, and this is the supervisory system. Okay. Now, going by the previous concept, sorry, it is okay. Now, going by the previous concepts of industry 3.0, what you would need is the processing has to be done in a serial way. Okay. There's an RFID tag, fine, but the serial processing means that um, let's say you need some basic ingredients. That's the resource one, and then a proper liquid has to be mixed with the basic solid ingredients to make it a shampoo. And then the third resource, what it is doing is it's putting in the color and the perfume required for different kinds of. So now the problem is, and then of course there's a manufacturing executive system (MES) that identifies what needs to be done, and then it talks to the ERP, which does the controlling part. Now, so based on what kind of color and perfume is required, and what kind of shampoo is required, the bottle is filled with. Now, the problem is what happens if one of the resources, let's say this resource, is not working. So it will halt the entire production line. Or, for instance, there's some problem with the supervisory system, and it's not able to judge what's going on, and so it will create all the problems. Now, to get rid of such kind of problems, the industry 4.0, what it does is, as we all know, all the components are converted to CPS. So all these resources that now they become cyber physical systems, and when they become cyber physical systems, they all have similar capabilities. So if there's one resource failing, the other resource can take its place and can perform the tasks that were given to the resource one. So R1 has failed, but R2 is able to carry out the process of R1 and R2 both. But not just that, the CPS can also self-diagnose and figure out. Oops, sorry, and can figure out the status of the production line and how it is to collaborate with other CPS in the process. Now, when we design CPS, we eventually don't need this MES supervisory system. So we get rid of one component from the system because the CPS by themselves are able to make decision, and all they need is just the controlling station, and that's it. So the shampoo bottles will be fitted with the RFID tags to identify which brand and variant it is, and then in the production it goes on there. It goes to the production line. I mean, the controller sitting there, SCRP. It decides on what to do next. So it's, it's like using Industry 4.0 concepts. The physical systems were converted to cyber physical systems, which are autonomous, can make decisions, can assess themselves, and are able to fill in different kinds of perfume You don't have to change the production line, so on and so forth. Now, let's talk about why this smart manufacturing we've been talking about is so important. Now, oops, yes. You don't see, but I can see many windows, so I need to sometimes, take them up and down. Okay, fine. Now, Industry 4.0, what it requires is a collaboration between companies. Why I'm saying companies because your raw material comes from one company. Your other, uh, for instance, you need some components to create a product in your company. So you're purchasing from other companies. You're also dealing with the government. You're also dealing with the institutions for new research, and so there's so much going on. And so what EU, like I mean, the European Union and the United States, what they have done is they have set up some initiatives to fund this kind of smart manufacturing. Um, so lots of funding is given to the industry to change their infrastructure that suits to the industry 4.0. But again, in a global perspective, there is one organization is called Industrial Internet Consortium, and they're sponsoring a number of collaborative projects. So, and these projects they call test beds, and companies like Infosys, for instance, like Infosys is working with Bosch, PTL, PTC, and Intel, and they're all collaborating on an effort on a test bed, which is called asset efficiency test bed. Now, this is really interesting how this global initiative, which I'm talking about, this Industrial Internet Consortium, it actually can sponsor, it can fund an industry in India and help it for implementing this Industry 4.0 concepts. Now, it's why this goes on is because the companies they help each other, and this asset efficiency test bed that Infosys is working with other international companies is quite similar to the one we say lean manufacturing or smart manufacturing. So what they're doing is they're trying to reduce the weight. I mean, reduce the waste, and they're trying to improve the maintenance and uptime. Now, these test bed projects in different arena, they are focusing on different kinds of uh, products, and this is just an example which I shared with you here. So, because it is important, government and there are uh, private actors who are coming to help. Now, with with the advent of Industry 4.0, there might be a question like who's going to be the winner and who's going to be the loser. So definitely, when there are winners, the others should be the losers as well. But with Industry 4.0, there are more winners than the losers. So if you look at these developed countries like United Nations and European Union, and these are the companies where they can easily implement this Industry 4.0 concept. They can quickly convert to to smart manufacturing sites. But the thing is, why China's market or Indian market was getting an edge over others is because we had cheap labor. Whereas these rich nations, they don't have cheap labor. I mean, if you talk about US, there they have to pay a laborer around $28 for an hour. If the worker is working for 8 hours, he would easily get more than $200. Now, this $200 is something like more than 15,000 Indian rupees, and definitely we are not able to pay. And because their labor cost was higher, so their product cost was higher as well. But with this Industry 4.0, definitely because they don't need much labor. I mean, it's going to be a completely light, switched off company or industry. So these developed countries are going to be benefited more than countries like China and India. But here again, China and India, they also know the importance of this Industry 4.0 revolution. And because, it's kind of providing customized products to the entire world. I mean, the entire world is your market, and 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 the difference between the business and the customer is also diminishing. The business can become customer, and the customer can become business. So it is said that the fourth industrial revolution, which is Industry 4.0, is going to be advantageous to all, including Western countries and Asian subcontinent, and it's like win-win situation for the customers and the business. Now let's quickly take some real-world small factory examples. We still have half an hour. So General Electric's, if you have heard about, it's a big company, and they have more than 400 manufacturing service plants. Now they have come up with the concept of brilliant factory. In fact, GE was the one who coined this word for this industrial Internet of Things workforce, and so they are still ahead in when it comes to implementation of this 4.0. So what they aim is they want to transform. They want to transform their traditional manufacturing plants by digitally connecting them, and so they are going to design a digital thread to allow them to kind of design, manufacture, and service their products. What they're targeting is their key performance indicators. They should be increased 20. They should be they're aiming to increase them 20% in uptime, and 10% are they looking for in the throughput in their production volume. So GE is ahead of everyone else. There's another example of Airbus. Um, they are working with National Instruments. The National Instruments company is not new. You all know this. You might have instruments in your institutions which have been brought by National Instruments. And the National Instruments is one which is promoting MathWorks or MATLAB also. So the National Instrument, they collaborate with MathWorks, but they're not promoting, of course, because National Instrument, they have their own softwares and lab. If you have worked with LabVIEW software, you would understand that this LabVIEW is developed by National Instruments. The company has bases in most of the countries, and I guess they have one head office in Singapore. So this National Instruments, with the help of National Instruments and Airbus, they're trying to create a future factory. So for the first phase, what they're targeting to reduce their mistakes and the wasted time material. So it's basically the concept of lean manufacturing. And the second stage, and the important, I mean, the peculiar thing that they have is they have provided their workers with a cell phone, and the cell phone has an application called Toolbox Talk. So Toolbox Talk has all the information that the worker needs while working. So everything regarding, I mean, all the information regarding workers' work is there on the app, and as and when worker has any question, can actually go to the web to the application and get the answers. Another good example is this Siemens Hamburg electronic plant, this EWA. You would probably know that Siemens is world's leading PLC supplier. They're making program logic circuits, and they've been used worldwide in to automate machines, equipment, processes. The PLCs are used everywhere. So they're used in skylift, they're used in cruising ships, they're used in locomotives, they're used in everywhere, in all walks of life. Wherever you need automation and control, you use PLCs, and the PLCs, they normally come from Siemens. For now, with their capabilities, Siemens, they produce one control unit, one PLC, they produce every second. So in one day, they produce more than 100,000 close to 100,000. Now, see the defect rate is so small. It's like 0.00115%. And the production quality is close to 1. And then to achieve this, what they've done is they put 1,000, more than 1,000 scanners. They document each and every step of manufacturing process real time. And then because the products they all have RFID tags on them. So they gather all the information and would sort out any defective part in the process until the finished product is sent out for packaging. So the entire process is so robust that they they have a defect rate of 0.0015%. 0.0015% means out of 100, not even one. It's like out of maybe 10,000, there's one defect part, and that's also being discarded. So if you look at Industry 4.0, it has, you know, it is the center of so many other things. So we have services such as inventory control, logistics, smart transport. They are all there to reduce the cost, improve efficiency. Right? But as you see, um, we have suppliers here. Sorry, we have suppliers here, and then the entire supply chain has to be optimized. And then some smart data, new business, big data system. We talk about everything, but the central core of everything is this Industry 4.0. So it kind of makes use of all this and the clear manipulations, and then yeah. So we understand how smart manufacturing or the manufacturing overall is being affected by Industry 4.0 implementation. And gradually, I guess those who are listening to me would have an idea of how we are achieving, how this Industry 4.0 is going to help us. Now, it's just not the manufacturing. There are other industries such as healthcare, defense, um, transport. There are many different sectors, and they all gets benefited from the Industry 4.0 concepts. Now, I'll quickly go through some more examples if we have time. Yes. So, if you talk about healthcare, the healthcare, if you implementation of Industry 4.0 in healthcare can influence the healthcare research, healthcare givers, emergency care in healthcare, medical information distribution, and devices used for healthcare. So these are the areas which have potential implications of Industry 4.0. Before talking about these individual components of healthcare, I'll give you a few examples. For instance, a smartphone. A person who is admitted in a hospital can be given a smartphone, and the person should be able to kind of monitor everything. Or a person after discharging from the hospital comes home with a application on his phone that tells everything about the person's health status. The Scottish Healthcare, they designed a robot called Zira. It was meant for dementia patients, and so was trying to keep the morale high of these patients. It was a physical robot which would interact with the patients. There's another robot called Baymax. It was kind of a teddy bear, and there's another similar teddy bear robot that was developed by MIT Media Lab. So there are robots, there are applications, and there are systems to interact where the person is interacting. But behind these, there's so many things, and we'll talk about how Industry 4.0 is positively affecting the healthcare research and other aspects. Now, through big data analytics, we can get more information. We can have access to the information which we never had before. We can find better solutions which we could never find before. So it is expected that with the increased capability, so with the support of Mr. Points in the medical field, you can do all this. I mean, innovative studies to a patient data can be analyzed and can be shared. I mean, patient data can be shared with other hospital whenever you have, that kind of expertise to treat the person. We talk about tele robotics or telemedicine these days. So it kinds of help in all. So in particular, we are talking about the research, and the research basically is finding something more from the existing data. That is with the help of big data analytics, uh, and then using this Industry 4.0 concepts, which basically talks about robotics, augmented reality. With augmented reality, you can train your, PG students in medical medicine. You don't need a cadaver or a real patient, and so there is so much that can be done in healthcare research. Talking about the caregiving, a caregiver would have an app with all the information on how to deal with the patients, and so with the equipment, the mobile, which is equipped with many sensors, and apart from that, uh, the caregivers, they can they are available. They are available online in a virtual mode to the patients, and so one healthcare giver is able to contact many patients at the same time and can help them. Similarly, if you talk about emergency care, there are many kinds of emergency care that we need in healthcare system. For instance, you need ambulance services. Right? There's an ambulance, and it has picked up a patient, but uh, it got jammed. It got stopped into a traffic jam, for instance. So, with the help of Industry 4.0 concepts, how we can solve this problem is that uh, the ambulance, once contacted, would have accurate position location of the patient, right? And reaching to the patient um, with certain sensors, it can let the hospital know the exact situation of the patient. If it is very urgent, then what happens is the hospital system is connected with the traffic light system. So the route this ambulance is taking, they would make sure that all the traffic signals are green. So they would create a green corridor, and so it will not stuck into traffic jam. Or maybe there's some accident. Uh, maybe there's some accident. So it can reroute the way ambulance reach to the hospital and helps in quickly providing treatment to the patient. The other kind of emergency we see is vehicular accidents on the road. So there may be, we normally have airbags in our cars. So with the airbags, there can be a sensor which can detect this fatal accident and can send the data through GCM or through internet to the hospitals or to the trauma hospitals, which later can take appropriate action. For patients emergency again, let me switch. Yeah. So there are sensors with the patient who would keep sending information, and as and when the patient is need emergency services, it will be notified. So we have many such kind of internet protocols, and so once you convert all your healthcare entities into CPS, then you can work with the communication protocols, such as we have wireless LAN or wireless body area networks and these kind of things. So, I mean, we these days we have many options for communication, for access of expertise, and and the technology is also. So everything is connected. I mean, if I need to connect to a specialist or a doctor, so all I need to do is contact the hospital. The hospital would connect to the doctor. Doctor can access my entire health status to because everything is available to doctor as well. And based on that, the doctor can suggest a treatment, and that goes into the system again. And so, uh, with minimum human components, the entire process can be efficiently automated. So if you talk about these devices, a few of these devices I have mentioned here, but the number is not limited to these. There are many more devices. So, for instance, I mean, these are the devices which have recently come up, like smart continuous glucose monitoring meter. So, what it does is there's a small patch. It continuously monitors the glucose, and it would induce the required insulin in a closed loop control circuit. So, in a controlled manner, the insulin can be supplied to the body. There are sensors which can be given in pills to people. You know, there are old age people who would forget if they've taken the medicine around. So what happens is there's this small ingestible sensor which will come out of the body without doing any harm, of course. So the sensor is inside the pill, and the person, when it takes the pill, inside, when the pill is dissolved, the small signal will be uh, given to the sensor outside. The person is will be wearing a bandage, and so the signal would come that you've taken the medicine. And if you've not taken the medicine, there is no signal. So the doctors, they can easily figure out the medicine has been taken. This is something which has been implemented. And then there are smart contact lenses, like from the eye fluid. It's not tears, of course. Someone is not crying there, but the contact lens can take eye the fluid into the eyeball, and with this it can measure the blood glucose level, and if it is dropping or rising, it can tell, it can communicate, and corrective actions can be taken. There are other healthcare devices such as patient location tracking gadgets, health monitoring appliances. Person, old age people, they can wear these kind of devices in their home, and they keep communicating with the hospital. There are vital signs gathering devices. For instance, the person has fallen down, or if the heartbeat is uh, normal. There are few vital signs, and that these signs would raise an alarm to the hospital, and then ambulance can be sent to the person to help them. So basically, these are gadgets which can enhance your quality of life, can tell you how much you walked and how much your heartbeat and how much your cholesterol and all this. There are fitness bands as well. So these medical devices put together uh, becomes the CPS for healthcare system, and help us in implementing Industry 4.0 concept. Talk about oil and gas industry. So what happens there is, like, they do oil exploration, and then they do some CT scan of the um, oil well. After drilling to certain depth, they would do CT scan, and then they would figure out whether they can find oil or not. But then this information is to be sent to very far station. There are others, for instance. This exchange of information has to be done through internet, and there's huge volume of data, and it's not possible So they need to devise new ways to kind of compress the information, and then through a high-speed data distribution service, they can actually communicate. So oil and gas industry, they actually deal with a lot of data, and so with the data, if you do a big data analysis, you should be able to make out whether there's a chance of finding oil or not, um, because you have the data from the nearby uh, drilling well, I mean nearby oil wells as well. So these days they use a lot of machine learning and artificial intelligence in oil and gas industry, and that is one important component of Industry 4.0 concept. So with the help of Industry 4.0 concept, the oil and the gas industry, they they can survive, because the present workforce that they have is of course has a lot of experience, but because these employees they're aging and they're not replaced by the new people, and so you need intelligent systems to capture the experience of these people in a digital form, so that the future decisions can be taken. So with the help of the big data analysis and remote visibility, you can optimize your processes. These oil and gas industries, they have a lot of troubleshooting. For instance, augmented reality can be used to kind of maintain their equipment in far off side, because normally exploration sites are very far from civilization, and they need such techniques to troubleshoot their problems. For instance, I'm showing here in the picture down there, if you can see. So there's a turbine, okay, and there's a sensor on the turbine which says that the turbine is going to is going to go breakdown in 7 days. This information will be shared with the latest depot, where they would receive the message, and then they would send a truck with the turbine blades required, so that it reaches within time, and the blades can be replaced before a breakdown which would be really hazardous. Uh, the revenue, in terms of revenue, if you talk about here, this industry 4.0, it could increase the global GDP. I'm talking about the global GDP as much as 0.8%, which is like 860 billion dollars increase. And that's only the financial gain, but the saving on time would be again quite valuable. The real-time data captured in oil exploration sites using embedded sensors and automated data communication systems. It would help companies gathering more information and making more informed decisions whether to explore oil at that particular site or not. And with the real-time downhole drilling data, they and the information coming from the nearby wells, the companies can adapt their drilling strategies. So eventually, they have increased visibility and can, with the Industry 4.0 implementation, the companies can actually improve their production from 6 to 8%. Uh, it also helps, making processes less dangerous. And if you talk about in terms of environmental footprint, using less energy, avoiding oil spills and other accidents, basically are helping the environment. Oops. Once again, I'm just clear all my annotations and then move on. See, we talked about the oil and gas industry, but the buildings they're getting smarter these days, and I'll just leave it to you guys because the time's up. Time's up now. How do I stop sharing? Okay, once again. Oops. If I go full screen again, um,
Sir, your voice is not coming. Excuse me, sir.
ah, is it okay now? Can you hear me?
Yes, sir. Now we can hear you. Thank you.
So when was I muted? I don't remember. Maybe recently, right? Maybe a few seconds back. So with this, we concluded our discussion on Industry 4.0, and I guess you've had a preliminary idea of what this concept is and how it encompasses all the recent advances and novel findings and technologies that exist today, encompassing everything put together and bundled into something we call as Industry 4.0. So if you have any question, we can quickly take it up. We still have a couple of minutes. I guess there's a following session. I mean, there's a session following after my presentation. And so if there are no questions, we can stop here.
If any of the participants wants to ask any question, you can unmute your mic or you can type in the chat box as well.
So
Thank you,
since there are
Dr.
no
Nishant,
question,
sir.
yeah, thank you very much
Yeah,
for inviting me here. And I was really happy in sharing what I know about Industry 4.0. And in future also, you can contact me anytime using my email ID or my cell phone. Thank you so much, Mr.
definitely, sir. We
Sharma.
will definitely contact you for further sessions like this.
Sure,
And
sure.
we are very much delighted to have your
Thank
presence
you.
here.
Thank you, Mr. Prasad. Thank you, Mr. Sharma. And yeah, enjoy the rest of your day. And I'll log out from here now. Thank you very much.
Thank you, sir.
Thank you, Ashish. Thank you.
Now there is a 10 minutes break. All the participants are requested not to leave the meeting. They can take a break. The next session will be of Dr. R.K. Gupta from Manipal University, and it will begin at 11:55 sharp. Good morning, Gupta sir. Good morning, sir. Dr. R.K. Gupta. Morning, sir. Sir, your voice is not coming.
Hello, sir, your voice is not coming.
The session will begin at resume at 11:55 a.m., sir. But still, your voice is not coming, sir.
Hello.
खाना खा लिया तूने? अब जाएगा, टाइम हो गया। अरे आ जा रे। हैं? रूम पर ही है, आना ऊपर।
Participants, you are requested to wait for 5 minutes. Very soon we will start off with the session.
Hello. Gupta sir.
Hello. Hello.
Sir, we can hear you, sir.
Yeah.
भैया
So, shall I share my slide or let us
Yes, sir.
wait
You
for?
can. Yes, sir.
Okay, I'll go on the share
Sir,
content.
please turn on your video for a while, sir.
Okay, okay. It's now on.
Yes, sir. We can see you. Good morning, everyone. On behalf of Arya College of Engineering and Information Technology, I would like to welcome Dr. R.K. Gupta. Dr. R.K. Gupta is currently working as Director Admissions and Professor of Mechanical Engineering in Manipal University, Jaipur. Dr. Gupta was Deputy Director, Quality and Compliances, and successfully led the NAC accreditation process with A plus grade. He has a rich and versatile teaching, industrial, and administrative experience of over 26 years after his graduation. Dr. Gupta started his career from MBM Engineering College, Jodhpur, and has served for prestigious institutions in various capacities like Head of Department, Controller of Examinations, Director and Dean Academics. Dr. Gupta developed departmental laboratories and handled inspections of AICTE affiliation universities, National Board of Accreditation, and NAC. He has also been organized various state-level competitive examinations during his academic career. Dr. Gupta has chaired number of sessions at international national conferences and has been invited as keynote speaker in various conferences. His area of interest in teaching and research includes industrial engineering, quality control, production and reliability analysis, and has published 55 publications. During his industry experience, he worked in research and development department and successfully developed tools for diamond polishing called diamond impregnated saves, diamond gripping dies, stone cutting tools used for marble and granite. I would request Dr. Gupta to continue with the session. Thank you, sir.
Yeah, thank you. Thank you, Dr. Love, for a wonderful introduction. So, I'm sharing my slides. Yeah, is it visible to all of you?
Yes, sir. We can see it. We can see the slides.
Yeah, thanks for the organizer of this workshop on manufacturing practices and Industry 4.0. Uh, I'm going to talk about the lean manufacturing, and there are different tools of the lean manufacturing, but I'll discuss on the only one tool about the cellular cell manufacturing, cellular cell. So before moving to this lean manufacturing, what is this traditional manufacturing, and then the comparison with the lean manufacturing. So in the traditional and the lean manufacturing, one is the key. If we implement this lean manufacturing, so what is the advantage? Means like from the traditional methods, it took half time, means half the hours of engineering efforts. Whatever the efforts we are means do for the traditional manufacturing, or if we do the for the product development, it also takes the half of the time. Means most of the time, 50% times can be saved in the engineering efforts, 50% time can be saved in development time by using the lean manufacturing. What is this? This also reduces the investment. Investment means investment in the machinery, investment and the tools, investment and the equipments. That also reduces. By this reduces it. It saves the lot of money, a lot of capital, and then it reduces the cost of the product. So then also reduces the human efforts by the implementing the lean manufacturing, and it also improves the product quality, or you can we can say that the reduces the defects in the finished product, and also it saves the factory spaces by using the lean manufacturing. Because of that, in the lean manufacturing there are lesser machines are required. So if lesser machines are required, then it saves the space. And then the 10th, or the less of in process inventories, that also reduces the in process inventories or the stock item stocks, right? So this is the lean versus the traditional manufacturing. Now the why we are thinking about the lean, why thinking lean? One is a specific value. This is specific value can only be defined by the ultimate customer. Means whatever we are manufacturing, whether the industry, small industries, or the medium industries, or the big industries, or the big entrepreneurs, what they are manufacturing all on the basis of the customer's demand. Like if you take an example of mobile phone, everywhere every year there are new mobile phones are coming into the market. So and the previous versions were updated in every year. So why they are? Because of that, they are means manufacturing, or they are developing a new mobile phone, or the new Android system, or the whatever the software used in the mobile phones, that is to be developed on the basis of the customer's requirement, or the customer's feedback, or the customer's satisfaction point of view, right? Then they identifying the value stream that means exposes the enormous amount of the waste, that reduces the waste. Like I'll take an example of mobile phone. Earlier we used to take the means for these saving the data in the pen drive, hard disk, or any other devices in the laptop. But nowadays everyone is having the mobile phone, or that mobile phone capacity is 64 GB or 20 or 32 GB or the 128 GB, and all the data informations can be saved in the mobile phone. Even the mobile phone can be used as a laptop. So it also exposes the enormous amount of the waste. From the manufacturing point of view, like from the it saves the material, right? Then they create flow, reduces batch size and the work in process. That also saves the many processes, many steps, can be reduced, and can be reduced the batch size also. Because of that, productions we are doing in the form of mass production, or in the form of batch size productions, or in the form of customized way. So that also reduces the batch size and the working process. Number of processes can be reduced with the help of this lean manufacturing. Then let the customer pull product through the value stream. Make only what the customers has ordered. So now is this lean manufacturing, what the customers orders, and we are manufacturing on the basis of that. There's a Toyota as the best example of that. That's why I have taken the uh, Toyota study. So other one is a seek perfection, to continuously improve quality and eliminate waste. So for the perfection point of view, means the customer's point of view, like this customer's point of view. So one word we always use: fitness for the use. Fitness for the use means like for the mobile phone example. Like earlier, that was a basic mobile phones. Nowadays, there's a customized mobile phones is also available, and the very good to is you can say that the iPhones. from the basic phone to the iPhone. Basic phone is available in 500 rupees and iPhone is available up to the 2 lakh. So, and but both the phones are used for the means calling, voice calling. And but other one is like perfection. What perfection you need means someone is needs to use this iPhone for the video calling, for the video shooting, or for the photo shooting like that. But basic phones can't be used. So means it is a perfection. Continuously improve quality and the eliminating the waste. So other one is, what is this lean? Lean means our production focuses on eliminating waste in process, like waste of work in progress and finished goods inventories. So eliminate waste in processes means in process inventories can be reduces, in process steps can be reduces, and that saves the inventory, that saves the time, that saves the cost. So lean production is not about the eliminating the main purpose of this means lean production is not like that. If we are going for the lean from the traditional manufacturing, that reduces the that manpower. No manpower can't be reduced by using the lean manufacturing. Manpower can, but skills sets are required for this lean manufacturing. So lean production is about expanding capacity by reducing the cost, shortening the cycle times between the order and the ship date. Like we have, I talk about the uh, by using the means a lesser number of machines are used, so it saves the space, and that space and that cost saves by lesser number of machine can be used for expanding the capacity, as well as the that shortening the cycle time between the order and the ship date. Between the order and ship date means if we are manufacturing on the basis of the customer's requirement, and this is the order means customer is ordering, and then we are manufacturing, and the when to be shipped. When to be shipped from the shop floor to the customer means from the receiving the order from the customer and shipping the product to the customer. In between that reduce the cycle time, and that reducing the cycle time, it saves the total time, it saves the standard time, it saves the then ultimately cost, and it increases the productivity of the system. So lean is about understanding what is important to the customer. So again, there is a lean means that makes the understanding if what is the important for the customer means what we last in the last slide what we have discussed, continuously improve quality and eliminating the waste. So seek perfection. Seek perfection means that important. What is the important to the customer? What kind of product the customers need, and what special things he required in the product, or what is his demand, and or what perfection he needs in the product. So that is the lean manufacturing. Then, if we define this lean manufacturing, like lean manufacturing, this is a philosophy which reduces the time between the customer's order and the product manufacturing shipment by removing and eliminating sources of the waste. So, if you look at this business, which is as usual is going on, means for the traditional manufacturing, we receive the orders from the customer, product to be made, manufactured, and shipped to the customer, and then between these two activities means receiving the order from the customer and shipping to the customer. Between these two, whatever the time is taken, and that includes the waste, because we have not eliminated the waste. If we reduce by using the lean manufacturing, again from the customer's order to the product manufacturing and shipment, then if we are by using, we can reduce the waste, and it is shorter time. Time can be means it saves the time. So frequently we can supply the customers means as per his demand, right? So that is the difference between the traditional and the lean manufacturing. So basically it saves the time, and time means time. If saving the time, reduce the cost, increase the productivity. So like before lean, and this is an example of manufacturing organization which is using the conventional flow. There is no setup, no proper setup, no proper control on the shop floor. Like that, a number of lathe machines are used by the organization, then the milling machines, then the grinder, and then the drilling. So there's an input from this means product to be started from this point of view of this point from the lathe one or any of the lathe, and then the different operations to be performed on the product or on the raw material, like the turning operation or the facing operation or the champing operation or the grinding operation or the milling, keyway, all these operations to be performed on the product. And supposed to be some of the product means any of the product means one product is doesn't require any milling operation or any grinding operation, that directly go to the grinding or directly going to the milling or directly going to the drilling operation, means skipping one or the another machine. So in this way, what is the problem in this type of setup? Means one is the important part is movement of material from one machine to the other machine. How to move it? Supposed to be a material to be moved from the lathe machine to the grinder, or from the lathe machine to the directly to the drill setup, or from lathe machine to the milling to the drill machine, or there may be some backtracking also. So it involved time, but that also increase the waiting time. Waiting time in this sense supposed to be here because of the system is not in an organized way. So from the lathe machine, it moves to the milling machine, and milling machine, which milling machine is to be moved? Because of that, usually what we have to do it, we have to do it nearby lathe machine. Means nearby lathe machine means we are moving from this lathe machine, from this lathe machine to the this milling machine, but not moving from this lathe machine to the this milling machine. So what is the loss of this? Supposed to be a, if moving from this lathe machine to the this machine or this milling machine, because this is the nearby machine, but this machine is still lying vacant. There is no operations going on this lathe milling machine. So we can move it from this lathe machine to the this milling machine, or from this lathe machine to the this milling machine, and we have to make it set up like that. So, but moving from this lathe machine to the this milling machine, we have to calculate the distance from this to this place. This to this place means what is the distance and travel time, and what are the steps moving from this machine to the this machine, that we have to calculate everything. So that's why the traditional means flow can be changed to the lean manufacturing. Because of that, it saves the travel time, it saves the cost, it saves the distance traveled and time taken into the distance traveled, and then it saves the waiting time, means reduces the waiting time and increase the or optimize the manufacturing time and reduce the standard time. Okay, so that's why they move it from the conventional flow to the lean manufacturing. And after lean manufacturing, what they did it, all these lathe machines and milling machines are arranged in a U-shaped layout. Right, this is the one example in the U-shaped layout, like lathe machine, then the milling machine, after the lathe machine, then the milling, then drill, grinder, milling, like that. So that study is gone, and after this study, they have arranged all these machines in the U-shaped layout that we call as organization and the control. So part is moving in a flow, in a flow in the sense the part is entering from this place, the operations to be performed on the lathe machine, and after this it will go to the milling machine, and then there's some keyway operation or any other cutting operations performed on the milling machine, then again go to the lathe machine, and then again go to the milling, and then drilling, and then the grinder, and then the milling operation. So means lathe machine, milling, lathe, mill, drill, grinder, mill machine. So if you look at this U-shaped layout, there are 2 lathe machines and 3 milling machine, and 1 grinder is required, and 1 drilling is required. Like if we go to the again conventional part, we require 2 lathe machine, 1 and 2 lathe machine as per the new system, and then we require 3 milling machines and 1 grinder and 1 drill. So instead of using the 4 lathe machine, 5 milling machine, 3 grinder, and 3 drill, total number of machine is 15 machines, and these 15 machines can be replaced with the 7 machines only. Means if you look at this, means after this 15 machines, all these machines are arranged on a shop floor, and that can be convert it in, reduces to the 7 machine. That saves the space, that saves the cost, that saves the time, as well as a proper flow of material is there in the lean manufacturing. So that is a difference using the lean manufacturing after the traditional or the conventional flow or conventional manufacturing. So what are the benefits of this lean manufacturing? There are one is the quality. By using the lean manufacturing, work is passed directly to the next process with no defect. There is a no defect, and then if the defects are not present in the system, and then the quality can be increased. The quality will be increased. So one is the quality. Then the other one is minimized waste, movement, warehouse, and double handling. That increases the productivity. If you understand like that, what is this productivity? Just this productivity is analogous to the efficiency. What the efficiency is means like output upon the input. And similarly, in productivity, what we are talking about output upon the input. Output upon the input means like what we want to manufacture a washer, and washer to for the washer manufacturing we need a sheet of steel, sheet of MS steel, MS plate, right? One is the material, then the other one is labor, means we require the manpower. Then for the cutting this sheet we require the machine, and for this other part man machine material, and then we require the electricity, we require the any other thing, capital resources, space, we need all this. Then means these all are the input, and what the input means we have to convert into the same unit, either in terms of the rupees, means how much amount to be paid for the purchase of the material, and how much salaries or the wages to be paid to the labor, and how much amount we have invested in the machines, not for the complete machines cost is to be included, means as per the requirement this machine cost is included for this production, and then how much amount we have paid for the electricity, and similarly any other input we have used. So what input we got from this finished washer, and the finished washer, and how much what is the cost of this finished washer, or what is the selling price of this finished washer, that is the output. So output upon the input means this minimize waste, movement can be reduced, right? Means that movement may be in the form of labor movement, means worker is moving from one machine to the another machine, or movement in the form of material is moving from one machine to the another machine, or the warehouses we are stocking for the for the stocking purposes, material to be stored or material to be storage in the warehouses. Then again we need the warehouses, and for the warehouses what we are paying the rent, or we are purchasing the warehouses, or we are paying the insurance, means, or for the some losses, means pulverized, or there are any other threats in the warehouses, or we are paying for the security, and then the double handling. So that is we can improve the productivity, or by the use of lean manufacturing, productivity is the best, is improve the productivity. Then the space, free up floor space for the new product, and the whatever the space we have optimize with the help of this, then can be used for the new products, right? Then the lead time, shortest supply chain, highest flexibility to satisfy the customer's demand. So initially what we have thought for what we have discussed, like from the traditional to the lean. From traditional to the lean means it reduces the time. It reduces the time means customers we can early delivery can be given to the customer. So, and other one is flexibility, highest flexibility to satisfy the customer's demand. Whenever the customers demanded for the new product, and we can supply it accordingly. As well as the supply chain, that also improve with the help of this lean manufacturing, means that is a lead time. So team member, by using this type of system, it increase the morale of the worker, it increase the satisfaction among the workers, value of the work is more visible, and recognize teamwork, as well as the joint efforts to improve the productivity, or joint efforts to improve the quality of the product or the efficiency. That is a team. So it increases the morale of the team. Then obviously by means increasing the productivity, quality increase, space utilization, team efforts, all this reduces the cost, as well as cost in terms of all other, means product cost, or the or any other cost that is involved in the product. So reduces inventory levels. Right. For this lean manufacturing, this is means what the conclusion of all this is systematic approach. Systematic approach for what purpose? Means to identify the waste and then eliminate the waste. So all these wastes are non-value added activities. Means that included in the traditional manufacturing, but in the lean manufacturing, whatever the non-validated activities we are removing, and that is called as the waste. This is in the terms of the movement of the worker, or the in terms of the material, or in terms of the machine. And through continuous improvement, while flowing the product at the pull of the customer in pursuit of the perfection, at the pull of the customer, right? And in the pursuit of the perfection towards the highest quality standard. Then if you define the lean manufacturing in terms of the value, that is capability provided to a customer at the right time, at an appropriate price, as defined in each case by the customer. So that is the value for money. So features of the product or services, availability, cost, performance are dimensions of the value. Like if you understand like that from the service point of view, like if you need any services required for the to repair the AC, or to repair the mobile phone, or any other feedback, or from the banking services, if you call immediately, then immediately you got the solution. So what they are doing means they have set up a call center for the customer satisfaction point of view. And immediately means like if you call for the AC repair or for the AC services, if you call to their customer care, means within 24 hours the service to be done by the organization. So the product or the services availability, cost, and performance are dimensions of the value. And then the waste, an activity that consumes resources but create no value, is the waste. So that's why the ultimate aim of this lean manufacturing is to reduce the waste. So that's why if we are means consuming our resources to create a product, and there's no value, then that is the waste. So what are the benefit of this lean manufacturing? One is the lean provides tangible benefits. There are many tangible benefits to be provided by the lean. Then the other one is reduces cost, not just selling prices. This also reduces the delivery time, cycle time, setup time, eliminate waste, seeks continuous improvement. And this is the continuous improvement and continuous improvement and continually improve. Then the improved quality of the product improves customers' rating and perceptions. That makes the faith among the customer. If you supply it on time, supply it the better quality product, it will give us a better ratings, and means it gives us perception among the customers. Then increase overall customer satisfaction, improves employees involvement, their morale, and company's culture, and helps transform manufacturers. That also helps in transformation in the manufacturing process. So these are the benefit of this lean manufacturing. For this lean manufacturing goals, like if you go to the ultimate goal of this lean manufacturing, one is a zero breakdown, no breakdown, then zero delays, zero defects, zero inventory, zero accidents, zero paper. So that is the ultimate goal of the lean manufacturing. But to thinking like that, we can reduce the delays. We can say that the zero delays. We can say that zero defects. We can say the zero accidents. We will make it the system like that. We'll go to the automation, zero paper, and then the zero breakdowns. But can it be possible to make it the zero inventories? That is the ultimate. So that was done. That study was done by the Toyota, and that successfully implemented in the Toyota. Toyota is the only organization who initiated this process and successfully done it initially. Now the every industries, or most of the industries, are using for the zero inventory. Right. So what are the different waste of the lean? One is a transport, other one is inventory, other one is motion, waiting, overproduction, over processing, defects, skills. So these are the 8 waste of the lean manufacturing. So first one is like we'll go to the transport, the movement of this people, movement of the tools, movement of the means inventory movement, equipment movement, or the product. So people movement is like we can say that the moving of the people from the or the worker from one machine to the another machine or moving on the shop floor. All right, that is also part of the means reduce of the wastes. Then tools movement, we are not keeping the tools on the one place as per the requirement. Then the inventory movement, unnecessary movement of the inventory. Invent means like we are in the flexible manufacturing system. We are making the storing the all this inventory or the keeping the stocks in the store at the one place. Means primaries we call as the primary storage, and then moving all these into the secondary places, secondary storage nearby to the machine. Then we call as secondary storage. So this is the movement of the material and keeping stock in keeping the item into the inventory. This is also more means not a part of this lean manufacturing. Then the equipment, movement of the equipment, then the product movement, whether the finished product or the semi-finished product or the raw material. So that to be reduced by this in this lean manufacturing. So excessive movement of material can lead to the product damage and the defect. That also part of this system. If your material is moving from one machine to the another machine, that may be lead to the defect. So excessive movement of the people and equipment can lead to the unnecessary work, greater wear and tear, and exhaustion. So these unnecessary movement can be reduced by improving the layout. This layout means like what we have taken the example of the U-shaped production line or the creating flow processes and not overproduction work in process item. Right. So transportation is the one part of this lean manufacturing, means wastages of in terms of the transport. So we have to do it lesser movement of the people, lesser movement of the tools and the equipment, lesser movement of the raw material, lesser movement of the work in process inventory, lesser movement of the finished product. So that improve the our system. So other one is second one is like inventories. What is if we are keeping the excess inventory into the system? Why we are keeping the excess inventory in the system? What is the advantage of keeping the excess inventory into the system? Like for an example, because of that we are keeping the excess inventory into the system because we got the discount to purchase the higher amount of material. That's why we are keeping the inventory into the system. Or in the future rates are revised. So by keeping all these things, if we are purchasing on the discounted prices or rates to be revised in the future, that's why we are purchasing the raw material and keeping into the inventory. Does it feasible for us, or that is it for us? No, this is not the advantages for us. If you look at that part, keeping more items into the inventory into the system means you have to pay the space rent, you have to pay the security charges, you have to pay the damage. Means keeping the item into the inventory, maybe there may be some like chemical aging is there, right? So product defects or the damaged materials or greater lead time and inefficient allocation of the capital. Sometimes because you got the discounted material on the discounted prices, so most of the means capital gone to purchase this item. Most of the space is gone to keep these items into the inventory. So this is the more dangerous. So excess inventory is also to be reduced. Or ultimate aim in lean manufacturing is the zero inventory. Means as and when you require the item, you place the order before that, and the item to be delivered by the vendor at that time. Okay, so that is the one part. And the other part, excess inventories can be caused by over purchasing, overproduction work, because of the items are into the inventory. So we have to consume that item in the inventory. So we'll do the overproduction. So there is a more work in process, more finished products are there, more utilize, more workers or more staff is engaged to manufacturing, and more machines are also engaged for the manufacturing. So or producing more products than the customers need. But demand is not there, but still we are manufacturing the item and keeping item into the inventory. Then excess inventory prevents detecting production related problems. If we are keeping the item into the inventory, and then that also another problem, we can't detect the defects into the inventory. or into the production. So production related problems were increased by keeping the item into the inventory and have time to accumulate before it is discovered. And this is going to be accumulated and accumulated. As a result, more work will be needed to correct the defect. So there are defects, means two types of defects. One is the rework or the scrap. So that may be increased scrap, that may be going to rework. Like similarly in the office inventory, what we do it, keeping the file waiting to be worked on. Means files are piled up and we are not working on that. Then piled up and increasing the inventory of the files. And then the customers waiting for the services, unused record in the database or the obsolete files. Let's take an example for the service point of view, customers waiting for the services or unused records in the database. Like if you purchase an AC of the LG, or if you purchase an AC of the Carrier, or if you purchase an LC of Blue Star, AC of the Blue Star or the Deccan or any of the organization, best services is the LG. And the initial cost of the LG AC is lesser than the all other product. But some of the companies doesn't have their service center in the Jaipur. So if you call at the LG service center, immediately your problems will be resolved. If you call it for the Blue Star, maybe their service centers are not in the Jaipur, so that it takes 2 to 3 days. Means it is the waiting time. And during summer, you can't wait for 2 to 3 days, or you need the service immediately. So customers waiting for the service, unused record in the database, or the obsolete files. And you're also keeping the files, obsolete files. Like we are from the education part of the education systems. Like you are giving the examination, and your copies to be kept for the next 3 years or the 4 years. This is the system. Yeah, we are keeping all these copies for the next 3 years or the 4 years, and after that we'll destroy it and we'll give it to the some kawadi wala. Usko copies ko de dete hain after destroying. But what the next system means, what is the improvement in the system? What we can do it. So immediately after the examination, we make it the soft copy. We'll scan all these copies and keep it into the system. So and destroy all these copies immediately. That reduce the space. That saves the time. Because always you have to maintain the quality of these copies for next 3 to 4 years. Why we are maintaining the quality of these copies? क्योंकि उसमें कीड़ा न लग जाए, कुछ और problem ना हो जाए उसके अंदर, and we have to maintain this quality of, means we maintain the proper system, right? So making the soft copy all these answer scripts, we can save the time and we can save the cost, like the CVSC is doing. So other part is manufacturing inventory waste could include broken machines. So broken machines also part of the inventory. Like machine kharab ho gayi, we are keeping this machine into the inventory, sitting around more finished products than the demanded, and we are manufacturing more finished product than the whatever the demand. Right? Means there's a difference into the supply and the demand. Then the extra material taking up the work space, and the finished products that cannot be stored. Like take an example of the Tata. Initially, what they made, when they launched the Nano, they have made it into the huge numbers, and all these Nanos are kept in the stores. And what they means more than the cost of the Nano, they have paid for to keep it into the inventory. So that is also increase the cost of the product. So what are these counter measures for this inventory system? That include purchasing raw material only when needed, or the purchase material only whenever you require. Not like that you are getting on the discounted prices and you purchase, like because and keeping into the inventory, that also increase the cost. And reducing buffers between the production steps, buffer stock between the production stock, and creating a queue system to prevent the overproduction, and make it a proper queue system, or make it a optimize queue system in the optimized way, so that we are not going for the overproduction. So that is for the inventory. Then the third part is motion. Motion means unnecessary movement of people, equipment, and machinery. Includes walking, lifting, reaching, bending, stretching, and then moving. So unnecessary movement of the people, like we'll take an example of for the motion is assembly part, assembly of nut and bolt. It means we'll take it one nut, we'll take it one bolt, and there are two washers to be there. So there's a complete assembly, means complete assembly includes one nut, one bolt, two washer. So how to do it? We can do it means keeping the bolt into the left hand and picking the nut from the bin, or before picking the nut from the bin, we'll pick the washer from the bin and then put it in the into the over the bolt and then drive the nut, and then this is the complete assembly. How can we then what the improvement can be done in this case? Because of that, in this case, one hand, left hand is idle and right hand is moving. So movement of this right hand, so it takes time. First step is right hand is moving from to search the washer, and then the again right hand is moving for to search the nut. That can be reduced. How we can reduce it? We'll move it both the hands. Right and left hands are moving. Left hand is searching for the bolt, and right hand is searching for the washer. And immediately at that place, after the searching and picking this bolt and the washer, and immediately washes to be put it over the bolt, and this left hand is idle, and then the again the right hand is not moving towards the body, it will move towards the again when where our nut is lying, and then they search the nut and then again do the assembly. So with this step-by-step processes, we can reduce the time. So ultimately, we have reduced the time in the form of fraction of seconds. But if we'll do it this for the 8 hours, or if we'll do it for the 1 week or for the month, if you calculate the time, it drastically reduces the time and saves the amount. So by that, and another part is like sitting position, means during the same assembly, if a worker is sitting and then how he is sitting, that posture is more important, right? So unnecessary movement of people, or unnecessary movement of the equipment, or unnecessary movement of the machinery, that includes the walking, lifting, reaching. Reaching means towards the material, towards the machine, right? Or machine is coming to us. Or the bending means while the assembly we are bending our body, means so while assembly there is only a trunk movement. That is only trunk movement. Not the complete body is moving. We are moving from the trunk only. And there is a eyes movement, right? Then the stretching and then the moving. So with the help of that, we can reduce the motion. Then in the office, what we have the wasted motion can include walking, reaching, searching. We are searching the files or reaching towards the file, and the files we have a n number of files piled up, and out of this n number of files piled up, we are searching the one file because we are not kept properly. So reaching towards the files, searching these files to get the material, searching for the files, mouse clicks, double entry of the data, or whatever it may be. So that is also part of the waste of the time in terms of the motion. Then the manufacturing motion waste can include repetitive movements. We are doing the repetitive movement, means moving like in the earlier example, moving from the lathe machine to the milling machine, and from then from moving from the milling machine to the lathe machine, or from the lathe machine to the milling machine to the grinding machine, and from grinding machine to the lathe machine. That is a movement. So machine to be arranged like that, so that we can reduce this movement. So movement that do not add value to the customer, reaching for the material, walking to get it to or the materials, or readjusting a component after it has been installed. So that movement can be reduced. Like if you look at the screwdriver, we are having the set of screwdrivers only the only hand means handle which is to be kept into the hand can't be replaced, but all the screwdrivers can be replaced, and this is kept in the one box. Otherwise, what we have to do it, we have to purchase the different kinds of screwdrivers and keep into the inventory. But now the screwdrivers are assembled, and we can move it anywhere. So what are the countermeasures for this motion? Can include making sure the workspace is well organized. Again, ultimately means design of the workspace. Then placing equipment. This is also the important part. Then the is placing equipment near the production location. So if you means this placing equipment near the production location means if you have gone to the any service center, whether it is two-wheeler or the four-wheeler service center, go to the four-wheeler service center. Every worker who is doing the servicing of the car is kept their own inventory of the equipment. near to that car or near to that their work area. So placing equipment near the production location, that saves the time, right? And putting materials at an ergonomic positions to reduce the stretching and the straining. This is also the another part. Then the fourth part is waiting. Waiting, the waste of waiting includes waiting for or on material or the equipment, and idle equipment can result in excess inventory and overproduction. Or the material is waiting for the equipment, or equipment is waiting for the material, or we are waiting for the machine. Machine means like sometimes in the mass production, what we are doing like that only. The machine is continuously doing the mass production, and other job is waiting for that machine. So, or some equipments are idle and can result in excess inventory and the overproduction. In the office, this waiting waste can include waiting for others to respond to an email. Means your customers that drop an email in the concerned person, and concerned person is not replying to that mail, and the customer is waiting for the reply. Then having files waiting for the review. Ineffective meetings means we are doing the meetings and meetings and meetings. In this meeting, next time for the next meeting is decided, but not this meeting not reaches to the conclusion. Then waiting for the computer to load a program, that is also a waiting time. What waiting time is means computer is waiting to upload a program. That is a waiting time, but not like that. The program is going on. Means we started the uploading the program into the desktop or in the laptop. That's not the waiting time. That is a working time. Okay. So in the manufacturing facility, waiting waste can include waiting for the material to arrive. That is a waiting time. Means we are waiting for the raw material. We have placed an order to the vendor and supplied so much material, so much means MS steel rods or so much machines or these oil, whatever. Means we have placed an order to the customer or vendor, and we are waiting to reach at the shop floor or to the industry. Right? That is a waiting time. Waiting for the proper instructions to start the manufacturing. We are waiting to start the manufacturing, and we are waiting from the instructions from the management. And having equipment with insufficient capacity. That is also a waiting time. Some countermeasures for this waiting time include designing process to ensure continuous flow or the single piece of flow. Leveling out the workload by using standardized work instructions, developing flexible multi-skilled workers who can quickly adjust in the work. So by that, these countermeasures, we can reduce the waiting time and improve this. So next one is overproduction. This is also a part of this lean manufacturing. If we are doing the overproduction, when we are doing the overproduction, when we got the material at discounted prices, or we have some other advantage by purchasing the material, or there's any other, the workers are idle or machines are idle, and we are doing the overproduction. That's not the good thing. The workers are idle, please engage all these workers to do the production, or the machines are idle to do the production, to engage all these machines, or materials gotten discounted prices, then we are doing the overproduction. So what is the advantage? If we are doing the overproduction, kept these items into the inventory and waiting to waiting for the sale. So overproduction occurs when manufacturing a product or an element of the product before it is being asked for or required. Nobody is asking to produce it, but ultimately we are producing because of anyone is sitting idle. So it may be tempting to produce as many products as possible when there is idle work or equipment time. However, rather than producing products just when they are needed under the just-in-time philosophy. Means what this just-in-time philosophy? We are means producing as and when required. As and when we receive the orders from the customers, then we are producing. So the just in case we have working leads a host of problems include preventing a smooth flow of the work, higher storage cost, hiding defects inside the work in process, requiring more capital expenditures to fund the production process, excessive lead time. So why this overproduction? What is this happening? Means that prevents the smooth flow, that increase the defects, also hiding the defects, increase the storage cost, defects in process inventory, or hiding the defects in the in-process inventory. We required more capital expenditure to fund the production process. But ultimately, our aim is what is this? To engage the equipment, to engage the machine, to engage the worker, right? That's why we are doing the overproduction. That's not the right thing. So excessive lead time. Additionally, overproduction of product also leads to increase in likelihood that the product or quantities of product produced are beyond the customer's requirement. Like in the office, how this overproduction is going on includes extra copies, creating reports on no one reads, providing more information than needed, and providing a service before the customer is ready. Or the manufacturing overproduction involves producing more products than the demanded through a push production system of producing products in higher batch size than the. So there are three countermeasures for this. First countermeasure is using a takt time. Ensure the rate of manufacturing between stations are even. Second one is reducing setup times, enabling manufacturing small batches or the single piece flow. Thirdly, using a pull or the convert system can control the amount of the work in process inventory. So these are the three countermeasures for this overproduction. One is the takt time, means rate of manufacturing between the stations. Right, means like that. If you take an example, earlier example of the U-shaped layout or the traditional the conventional manufacturing layout. So item is moving from lathe machine to the milling machine, and from the milling to grinding, and from grinding to the drilling machine, and then to the finished product. So supposed to be a lathe machine takes the 2 minutes, and then the milling machine takes the 1.5 minutes, and the grinding machine takes the again 2 minutes. So moving from lathe machine to the milling machine, right? So ultimately, milling machine is to be wait for the 0.55 second, 0.5 second, and similarly from milling machine to the grinding. So grinding takes the 2 minutes, and the early moving from milling machine to the grinding machine, it makes the pile up at the grinding machine. So we have to adjust all these machines and our production on the basis of the talk time, so that the time taken between stations should be even, and there is a no waiting and no over waiting, or the no piled up the in process inventories at one machine. Secondly, setup time can be reduced, enabling the manufacturing small batches of the single piece flow. So by reducing the setup time, how can we reduce the setup time? Making the fixtures or making the jigs. So frequently we can change it, whether it is we are producing in the form of small batches or the large batches, that can be reduced. Then thirdly, using a pull or the convert system can control the amount of the working process. So all this makes the reduce the overproduction. Then the sixth one is over processing. For this over processing refers to the doing the more work, adding more components, or having more steps in the product or the services than what is required by the customer. Means additional work to be done on the product, but not required by the customer. That is the over process. So that is to be done by the as per the requirement of the customers, and not like that we are doing some additional work, whether the customer is required or not required, but we are doing the additional activities over the product. So that is again over processing. Then this next one is office. In the office, over processing can include generating more detailed reports. Means we doesn't require the detailed report, but still we are producing the detailed report, and then this is the over processing. So do it whatever the required, not more than that, not lesser than that. Then having unnecessary steps in purchasing the process, requiring unnecessary signatures on the document, or double entry of data, requiring more forms than the needed, and having an extra step in the work. So what is this countermeasure for this? Over processing, understand the work requirement. What is the work requirement, and then do it on the basis of that. That is a countermeasure for the over processing. So next one is a defect. While producing means this is the fitness for use. If any product is not fit for the use, then ultimately this is the defective product. This defect may be in the form of scrap, or there may be form of the reworking. Means if product is undersized, then it is obviously it go to the scrap. If product is oversized, then we have to do it the rework. And doing the rework or doing the or waste of the product, that also increases the cost. But by the use of this lean manufacturing, that reduces the cost, and that reduces the defects and makes it the zero defect, or we can say that the defect free. So this both results are wasteful, and this includes additional cost to the operations without delivering any value to the customer. Right? Means scrapping a scrap product or the reworking on a product that increase the production, and that makes towards the overproduction, or that makes towards the overprocessing, that makes towards the inventory, that makes increasing the inventory. So all these wastages are also interrelated to each other. If one is affected, then from this one, other one is also affected. So without delivering any value to the customer. So what is countermeasures for this? Check most frequent defect and focus on it. So what kind of defect is there, and then focus on it, right? And then remove this defect. Design a process to detect abnormalities and do not pass any defective items along the production process. Like we are making like different kinds of charts, like XR chart, or P chart, or the U chart, or the C chart, and then we are identifying that what is this abnormality in all these. So this abnormality we can identify is sudden movement from the one product to the another product. Or you can say that to understand this means like a sudden movement from one sample to the another sample, that is also a abnormality. And there are two kinds of defects in this. One is the chance due to the chance cause of variation, other one is assignable cause of variation. Means one is the natural cause of variation, other one is assignable cause of variation. Natural cause of variation, there's an inherent in the system, means in the machine, in the measuring equipment, or like that, in that natural. But assignable cause of variations, maybe the reason may be the environmental, maybe poor our process, or maybe due to the temperature, or due to the any other effect. So that is to be identified. That's why we have mentioned as the most frequent defect to be identified, and then remove that. And process to be designed like that that detect abnormalities and do not pass any defective item along the production process. And then redesign the process so that does not lead to the defect. And use standardized work to ensure a consistent manufacturing process, that is the defect. Then the other one is, last one is for the waste of the lean is the skill. So skill means human skill. There are two kind of means you can say that the part of this part in the organization. One is the management, and other one is we can say that the worker, or the middle management, or the lower management. So what is unused human talent and ingenuity? So in the organization, if you are not using the human talent or their ingenuity, that also a waste. So in the organizations like that, the role of the management from the employees' point of view. What some organizations thought like that, management's responsibility is only for the planning, organizing, controlling, and innovating the production process. That is a thought of the management. But we are not involving the employees. We are not involving the workers in this for the planning purpose, planning in the organizing the activity, or the controlling the product, or the innovation in the product. We are not involving the employees. And without their involvement, there may be if we involve these work at the worker level also, we can improve all these four activities: planning, organizing, controlling, and innovating. Right? But not engaging the frontline workers' knowledge and the expertise means it is very difficult to improve the process. Or if we involve it, process can be improved in better way. So because the people doing the work are the ones who are the most capable of identifying the problems and developing solutions for them. Because of that, these frontline workers are doing the production. They are more keenly doing the production, or more involved. They're involvement in the process, and they understand in better way than those are sitting on the chair, or those are only making the planning. So frontline workers should be included, and their skill set to be used for this lean manufacturing, so that we can improve the planning, we can improve the organizing of the activities, we can improve the controlling of the production, and we can innovate the production processes. So in the similarly in the office, non-utilized talent could include insufficient training. Means if we are not utilizing the proper talent properly, then lack of training, then poor incentives, not asking for employees' feedback, means their feedback is the most important part, whether in the production, whether in the office, or whether in the organization, and placing employees in positions below their skills and the qualifications. So similarly, in the manufacturing, waste can seen the employees are poorly trained, they are not skilled, or the employees not knowing how to effectively operate the equipment because they are not skilled, so they don't know how to operate the equipment, or the employees are given to the wrong tool for the job when employees are not challenged to come up with ideas to improve the work. So that is the last set of waste. And if we involve the workers in the planning activities or any other organizing or controlling or the innovating of the product, obviously we reduce the waste. So this is all about the waste of the lean manufacturing. These are the 8 waste, and after this 8 waste, there are different kinds of tools are there. One is the 5 waste, value stream mapping, price work, load leveling, Kaizen, Kanban, visual workplace, quick changeover, and on Koka-yoke, one-piece flow, and the cellular. I will go on the cellular manufacturing, a small part of the cellular manufacturing. What is the use of cellular manufacturing in the lean manufacturing? Like by using the cellular manufacturing, what it reduces the lead time, manufacturing lead time, reduces the working process inventory, reduces the quality, improve the quality, simplify the production scheduling, and reduce the setup time. That is the advantage of objective of the cellular manufacturing. Like this is one example of the composite part, how we set up in the cellular form. That's why we have taken the example of the composite part. We are making an ideal part which is having the all operations that involve all the features of the part family. Part family features means all the design features, all the manufacturing features are included in that. So that we call as the composite part concept. So in this composite part concept, like we are doing the external cylinder design features, that is included in the turning. Face of the cylinder, like the facing. Cylindrical step, the turning. Smooth surfaces, external cylinder grinding. Axial hole, drilling. Counter bore, counter boring. Internal threads, tapping. So these are the corresponding operations with the design features. So why we make it the composite part concept? This composite part concept for a given family is hypothetical part. We made it a hypothetical part that includes all design and manufacturing attributes of the family. Means not these features are present in every product of the family, but some of the features are available in one part, other features are available in another part. But whatever the features having in the family, whether the design features or the manufacturing attributes, we made it a one composite part. So advantage of this, an individual part in the family will have some of the features of the family, but not all of them. But we are arranging our manufacturing facilities like that they can manufacture all, they can do all the activities of this composite part. Then production cell for this part family would consist of those machines required to make the composite part. Such a cell would be able to produce any family member by omitting operations corresponding to features not possessed by that part. Right, this is the composite part concept. Like we have designed the machine cell. One is the single machine cell, or the multiple machine cells with manual handling, often organized in the U shape, or the multiple machines with semi-integrated handling, or the automated cell. This is having the integrated handling, like we call it the flexible manufacturing cell or the flexible manufacturing system. So one is the like machine cell with manual handling. Means all these machines are arranged in the U-shaped layout, and from the one side part is going, and from the other side part is out. Work part is out, and we have arranged it like that. There is no waiting time, no idle time in this system. So U-shaped machine cell with manual part handling machine, that is arranged in the U-shape. So similarly, cells with semi-integrated handling means in the inline. If you want to do it in the U-shape with the help of semi-integrated handling, we can use the robots. Robots can be used to make it semi-integrated. So like similarly, inline process, again from the one side part is in and the part is out, and machines are arranged in the inline form. Then the third one is in the form of circular loop layout. We call as loop layout. That loop layout we can arrange in the rectangular layout also, in the form of ladder layout also. There are different types of layouts are available, right? So machines are arranged accordingly. So this is the cells rectangular layout. And then the most important part in the cellular manufacturing is the movement of the part. So like the machines are arranged in the form of like that in inline layout or the any other way of the layout. So that what kind of operations can be performed, and we have to arrange like that. One is a repetitive operation. Like the machine number one is supposed to be a lathe machine. Initially, we are doing the fishing operation. Then the second operation is the turning operation. Then there was some another operations to be performed, and the drilling operation or the chambering operations to be performed on the lathe machine. So this is the repeat operation. After that, means bypassing operation. Means part is to be bypassed another machine and reach to the next machine. Or this is the in sequence movement of the part. The machine component is moving from one machine to the another machine in the form of in sequence. Or part is skipping the one machine that we call as the bypass movement. Or part is moving after that backtracking, means to the previous machine or previous to the previous machine. So that is the backtracking. So four kind of means operations can be performed: repeat operation, backtracking, in sequence, or the move. So that's why there's a key machine concept is also involved in this. There's a one machine which is very expensive, or they perform certain critical operations. Like take an example of CNC machine that performs some critical operations, or the vertical of VHM, right, or the vertical machine or the horizontal machining centers, right. So these are the critical machines, expensive machines which perform the critical operations, and then the other machines are supporting this machine, right. So that we call as a key machine concept. So important to maintain high utilization of the key machine, and even if this means lower utilization of the support machines. So that is the key machine concept. So this is one more part of the cellular manufacturing is like how to arrange and what is the process of to arrange this machine on the basis of their utilization. So I have not included all this. So this is some basic concept of this lean manufacturing, and this is all about. Thank you very much to all for listening so patiently. Thanks. Thank you very much.
Thank you very much, sir. If any participant want to ask any question, you can ask directly. You can unmute yourself, or you can type in the chat box. Very soon, our principal, Dr. Arun Arya, will join the session. Also, Dr. Shilval, RTU event coordinator, will join us. So you are all requested to please stay and not to leave the session. Meanwhile, the participants can ask any question if they want, or they can type in the chat box. The feedback link is on. You can fill it up. Participants can fill up the feedback form provided in the chat box. You all are requested to please turn on your video so that we can have a photograph for the inaugural session. Closing session. I beg your pardon. Sorry.
We are just waiting for our principal, sir. So all of you, please on your videos for 5 to 10 minutes. Meanwhile, all the participants can fill the overall feedback form, which is shared in the chat box.
Good afternoon, all. We have with us Dr. Arun Arya, Principal, Arya College of Engineering and Information Technology. Now I will request the Principal, sir, to give a vote of thanks.
First of all, I would like to thank Dr. R.K. Gupta, Professor, Manipal University, Jaipur, for the today's session. This is the last day of our 5 days workshop on manufacturing practices and industry 4.0, which has been organized by our college, Arya College of Engineering and IT, and RTU Kota, is sponsored by TechUp 3. I am highly thankful to Professor Dr. Arya Gupta, Honorable Vice Chancellor, who has provided the opportunity to organize this 5 days workshop for the students. I would like to thank Dr. Dhirendra Mathur, the coordinator of TechUp 3. I also thank Dr. Shivlal sir and Dr. S.K. Sharma sir, the event coordinators of this 5 days workshop from RTU Kota. This 5 days workshop, in this 5 days workshop, all the speakers, all the experts delivered very good lectures, and all the lectures were highly informative, and all the students and faculties enjoyed a lot during these 5 days. I also thank all the experts, all the uh, participants, students, faculties who joined this workshop. I would like to thank Dr. P. Pandey, Professor IIT Delhi, uh, Dr. G.S. Dangayach, Professor MNIT, IIT Jodhpur, Dr. P.K. Jamwal, Sir, Associate Professor, Kazakhstan, Dr. M.L. Meena, Associate Professor, MNIT Jaipur, Dr. Ajitanshu Vadnam, Professor, A University, R.K. Gupta, Professor, Manipal University, Jaipur. Uh, these all are the eminent speakers of this 5 days workshop, and uh, due to their efforts, we could reach to the success of this workshop. I'm also thankful to the management of our college, Engineer Anurag Agrawal sir, Chairman, Arya College of Engineering and IT, for providing us the opportunity and to help on each and every step to organize this workshop. And I also thank the coordinator of this workshop, Engineer Sanjay Mandani, and co-coordinator, Engineer Sumit Sharma. I would also like to thank all the faculties and staff of Department of Mechanical Engineering, Arya College of Engineering and IT, and the other faculties of all the departments for their support and cooperation in this workshop. Once again, thanks a lot for all the guests, speakers, experts, the faculties from different institutions, and all. Once again, thanks a lot for attending this workshop. Thank you.
Thank you, sir. Thank you very much.
Sumit sir, I think all of the participants should is
Sir, your voice is not coming.
for a group photograph. All the students, all the participants and faculties, please start your videos.
Yes, please all are requested to turn on their videos so that we can take a photo. Thank you very much.
अरे वेट कर लो 5 मिनट आई
Sumit ji, should we end? Sumit sir,
Yes, sir.
should we end now? Meeting?
Voice is coming low, sir. Sir, thank you all for joining the session. And now we are going to end the session. Thank you very much, all of you, for attending the workshop. Thanks.